Well, hello. You seem to have found a video about programming FPGAs in C, which, if you're a software person, that probably sounds great, and if you're a hardware person, you're probably angry already at the word programming. But let's not waste any time and blink an LED. You're probably familiar with something like a microcontroller, maybe an Arduino, where maybe you have a timer running every millisecond, say, and you have some chunk of code, call it blink, that's going to be running every millisecond, and this is going to be the mechanism in which you're going to blink the LED. Hopefully that's not too unfamiliar. Okay, so to blink every second, say, we need to count up to 1,000. And to do that, we need some kind of storage of this counter. Call it a counter. It's an integer. And what does a counter do? It counts. +1 every time it's called, 1 millisecond increment. Hopefully not blowing anybody away here. We're counting up in order to toggle the LED, to turn it off or then on. So we need to know whether the LED is on or off right now so we can toggle it. And so we eventually make it up to 1,000, and if we hit 1,000, then we'll toggle the LED and reset the counter, and this is just keeps going and going, and that's how you blink an LED. Now on an FPGA, well, let's talk about clocks. Probably be running at something, I don't know, say 100 megahertz. So now this is running every 10 nanoseconds instead of 1 millisecond. So you got a whole bunch of iterations to count up to. But it's the same idea. And really, that's it. Now, does that exist in the real world? Can you go and compile this code? No. But there's PipelineC, which has this GitHub you can go check out, and it's a C-like hardware description language. So let's get on it. Let's start with bit accurate types. In PipelineC, you can get any bit width you want. So let's get some 27-bit and 1-bit numbers going on. Now, if this is hardware, so you're going to have inputs and outputs to some kind of module, and in this case, we're going to have a 1-bit output, which is the LED. We'll wire that out to the LED, and has no inputs. You can see how that takes place. Now let's give the compiler some information. What kind of FPGA part are we using to actually do this? And let's formalize that 100 megahertz target there and get onto real hardware. So you're going to have some kind of synthesis tool. You're going to go ahead and install that. There's instructions, and probably going to want some kind of example project to be inserting this code into. But you're going to run the compiler, and what it's going to tell you is, hey, great, your code will actually run up to 140 megahertz. Great. Like I said, it's generating scripts and code that you drop into the tool, hopefully with some kind of example project around it. vhdl, so any tool can support it. Here's Vivado. Tool generates a script, so that's pretty easy. Go with Vivado's flow just as you normally would. But let's get into maybe why this is a little more useful and cool. Hardware is hard, right? Let's say you want to do this at 200 megahertz. Functionally, it stays the same. You're just counting to a different value because you're doing it, every 5 nanoseconds instead of 10. Well, you're going to run the compiler again. This time it's going to tell you, oh, geez, you didn't meet your timing goal. And here's what it'll tell you. You used the counter, and you did 6.8 nanoseconds of logic to determine what the next value of the counter should be. Now you should be able to look at that, take a look at where you've used the counter in the code, and get an idea of where that's coming from. But the tool actually gives you an output as well. So it gives you this text file over here you can go take a look at, which gives you from top to bottom, inputs to outputs, what's going on in the logic of this function. So you could see first we're doing on line 15 this counter guy here, incrementing, Then after that's done, we're getting down to the equal check on line 17, and that takes place, and then you get the muxing and other things from the if here. Interesting note, the not here toggling the LED can take place, immediately. That kind of stuff will show up. So cool. How can you fix this? Well, you can still be smarter than the compiler at this point, and you can rearrange the code to do something like this, where now you can have the equality compare and the increment of the counter both taking place at the same time, because you've structured it. Instead of incrementing and then checking the value after the increment, you just check the value, one less than what you're trying to get to, and because you've structured it as an if-else, this counter here can be incrementing in parallel and is muxed at the end for the actual, what value gets stored at the end, just like you would expect in C. And you get a different map of the pipeline here. Yeah, still didn't make it though. Close, 197 megahertz. But anyway, this is just an example showing how, it's not software where you can maybe make it every millisecond. You have to make it every 5 nanoseconds exactly in this case, and if you don't, it just won't work. So that's basic register transfer language in PipelineC, which is kind of the core of your vhdl and your Verilog. But we didn't actually even talk on the pipelining part of PipelineC. I didn't even mention earlier the automatic pipelining that's built into the language. So something like this blink here has state of LED and counter, meaning that each time this blink happens every 5 nanoseconds, the logic depends on the previous 5 nanoseconds. So the compiler can automatically pipeline that for you. But if you give it something like a pure function with no state, just pure combinatorial logic inside, it'll pipeline away for you, and it'll graph the results there. And on the GitHub as well, more results. But then the question becomes, okay, these two kind of modes of writing here with your state versus your pure functions without state, then it becomes a matter of moving data in and out of these things, which I'm not going to get into now, but there's some links to go check out. And so, thanks. That's an intro to C on FPGAs with PipelineC. Go give it a try. Reach out if you want some help. I'm going to go back into my basement cave.